Ladies and gentlemen, this is Genevieve B. Portarques, and together with me, my partner, Daryl A. Gregory, for a vodcast on the nature of light. So, light or visible light is electromagnetic radiation within a portion of the electromagnetic spectrum that is perceived by the human eye. In physics, the term light sometimes refers to electromagnetic radiation of any wavelength, whether visible or not. In this sense, gamma rays, X rays, microwaves, and radio waves are also light. Like all types of electromagnetic radiation, visible light propagates as waves. However, the energy imparted by the waves is absorbed at single location. The wave particles are absorbed. The absorbed energy of the electromagnetic waves is called a photon and represents a quanta of light. When a wavelength or wavelight is transformed and absorbed by a photon, the energy of the wave instantly collapses to a single location, and this location is where the photon arrives. This is what called the wave function collapse. This dual wave, like a particle-like nature of light, is known as wave-particle duality. The study of light, known as optics, it is an important research area in modern physics. The primary properties of visible light are intensity, propagation, direction, frequency of wave spectrum, and polarization. Its speed in vacuum is 299,792,458 meter per second. It is one of the fundamental constants of nature. As with all the types of electromagnetic radiation or the EMR, light is found in experimental conditions to always move at the speed in a vacuum. So the nature of light has been a subject of inquiry since antiquity. So Isaac Newton performed experiments with lenses and prisms and was able to demonstrate that white light consists of individual colors of the rainbow combined together. Newton explained this optics finds in terms of a corpuscular view of light, in which light is composed of streams of extremely tiny particles traveling at light speeds according to Newton's law of motion. So other in the 17th century, such as Christian Huygens, and shown that optical phenomena such as reflection and refraction could be equally well explained in terms of light as waves traveling at high speed through a medium called luminiferous ether that was thought to permeate all space. Early in the 19th century, Thomas Young demonstrated that light passing through a narrow, closely spaced slits produce interference patterns that could not be explained in terms of Newtonian particles, but could be easily explained in the terms of waves. Later in the 19th century, after James Clerk Maxwell developed his theory of electromagnetic radiation and shown that light was a visible part of a vast spectrum of electromagnetic waves, the particle view of light became thoroughly discredited. By the end of the 19th century, scientists viewed that physical universe as roughly comprising two separate domains, and these are matter composed of particles moving according to Newton's law of motion, and electromagnetic radiation consisting of waves governed by Maxwell's equation. Today, these domains are referred to as classical mechanics and classical electrodynamics, or classical electromagnetism. Though there were few physical phenomena that could not be explained within this framework, scientists at that time were so confident of the overall soundness of this framework that they viewed these abbreviations as puzzling paradoxes that could likely be resolved somehow within this framework.
The nature of light. Light is a transverse electromagnetic wave that can be seen by a typical human. The wave nature of light was first illustrated through experiments on diffraction and interference. Like all magnetic waves, light can travel through a vacuum. The transverse nature of light can be demonstrated through polarization. Light is sometimes also known as visible light. In contrast, it from ultraviolet light and infrared light. Other forms of electromagnetic radiation that are not visible to human are sometimes also known as informally as light. Light has the properties of wave and particle. The word wavelength is used to express the wave or undulating property of light. It is the distance of that light travels in one oscillation and is often expressed using the unit called nanometer. 1 nanometer is equal to 1 billion of a meter. Our eyes can only see light that is of a wavelength between approximately 400 to 700 nanometers. The range is called the visible light. The light of other wavelengths include X-ray, ultraviolet rays, and infrared rays. Though we cannot see them directly, these are also members of the light family. On the other hand, light also has the property of a particle. The intensity of the light varies depending on the number of particles. Bright light has many particles while dark light has fewer particles. These particles of light are called photons. When we check out the particle property of light by comparing light with sound using a device called oscilloscope, sound is known to have the characteristic of a wave. Actually, when the intensity or magnitude of sound gradually weakens, the signal of sounds becomes smaller and eventually disappear. However, when light gradually weakens, the overall quantity of its signal becomes less, yet the few remaining pulses, or extremely short signals, can be detected, and the size of these individual signals does not decreases. This tells us that light cannot become any smaller, that light has a property of a particle. Light travels at the speed of about 300,000 km per second. Surprisingly, light can travel around the Earth 7.5 times in a mere 1 second. This property of light is utilized in many technical applications such as optical communications, which transfer huge data in a very short time. However, even light, which is faster than anything known to man, can move only 0.3 millimeters in a trillion of a seconds in a vacuum. In recent years, research of such optical phenomenon that occurs in this unavailably short period of time is becoming essential in a new research field of physics, chemistry, biology, and others.